What is edge computing? Have you ever imagined what it would be like to sit back and relax while your car drives you to your destination? With the rise of autonomous vehicles, this future is closer than you may think. However, there are still many challenges that need to be overcome before self-driving cars become a common sight on our roads. One of the biggest challenges is the need for real-time processing of large amounts of data. That's where edge computing comes in. Edge computing is a distributed computing model in which data processing and storage are performed closer to the source of the data, rather than sending all the data to a central location like a cloud server for processing. In edge computing, processing and storage are located at or near the edge of the network, which could be a mobile device, an Internet of Things, IoT, device, or a sensor. The idea behind edge computing is to reduce the latency and bandwidth requirements associated with sending data back and forth to a central cloud server. By processing data at the edge of the network, it can be analyzed in real time, enabling faster response times and more efficient use of network resources. This is especially important for applications that require low latency, such as video streaming, online gaming, or autonomous vehicles. Edge computing can also help reduce the cost and complexity of managing large amounts of data generated by IoT devices. Instead of sending all the data to a central cloud server for processing and storage, edge computing can perform data filtering and aggregation at the edge, sending only the relevant data to the cloud. This can help reduce bandwidth requirements and improve the overall efficiency of the system. Edge computing can also provide greater security and privacy for sensitive data. With edge computing, data is processed and stored locally, reducing the risk of data breaches or unauthorized access to sensitive information. This is especially important for applications like healthcare or finance, where data privacy and security are critical. Overall, edge computing is an emerging technology that offers a range of benefits, including improved performance, reduced costs, greater security and privacy, and more efficient use of network resources. As the number of connected devices and the volume of data they generate continues to grow, edge computing is likely to become an increasingly important part of the computing landscape. Let us come back to our example of autonomous vehicles. Autonomous vehicles rely on a wide range of sensors, such as cameras and lidar systems, to perceive their environment and make decisions about how to navigate the road. These sensors generate huge amounts of data that need to be processed in real time. However, sending all this data to a central cloud server for processing can be slow and inefficient, leading to increased latency and potentially dangerous situations. Enter edge computing. By processing data locally on the vehicle itself or on nearby edge devices, such as roadside sensors or other vehicles in the vicinity, edge computing can help reduce latency and improve the performance of autonomous vehicles. This means faster and more accurate decision-making, which is essential for ensuring the safety of passengers and other road users. But that's not all. Edge computing also offers improved security and privacy for autonomous vehicles. By processing data locally, the vehicle can reduce the risk of data breaches or unauthorized access to sensitive information, such as location data or passenger information. This is especially important given the increasing concern over data privacy and security in today's digital age. So how does edge computing work in practice? Let's take a closer look at an example. Imagine you're driving an autonomous vehicle down a busy street. As you approach an intersection, the vehicle's sensors detect a pedestrian crossing the road. The vehicle needs to make a decision about whether to stop or continue driving based on the pedestrian's movement. This decision needs to be made quickly and accurately to avoid a potential accident. With edge computing, the processing of this data can be performed locally on the vehicle itself or on nearby edge devices, such as a roadside sensor. The data from the vehicle's sensors can be quickly analyzed to determine the pedestrian's movement, and the vehicle can make a decision about whether to stop or continue driving. This all happens in real time, meaning that the vehicle can make the decision quickly and accurately, reducing the risk of accidents and improving the safety of passengers and other road users. As you can see, edge computing has the potential to revolutionize the way we think about autonomous vehicles. By reducing latency, improving performance, and increasing security and privacy, edge computing is a key technology that will enable the development and deployment of self-driving cars in the future. So the next time you imagine sitting back and relaxing while your car drives you to your destination, remember that edge computing is making this future a reality. Thanks for watching.